There is a famous quote in software: if debugging is the process of removing the bugs, then programming must be the process of putting them in. And nobody in their right mind can deny that. We create bugs while programming, while coding. And most of the time it happens because we do not know what state our system is in. We all have heard about object-oriented programming, procedural programming, as well as functional programming. But today I'm going to talk about something totally different, and the name of that thing is state machine based programming. I'm going to talk about that, but before that, let me ask you a question. I'll make a statement and you need to tell me what is the meaning coming out of that statement. Here comes the statement. I don't know what state he was in. He just didn't listen to me. Now, what is the meaning that you are deducting out of this particular statement? The meaning is that I was talking to a person and the person was in a totally different state or mood, and that's why he didn't listen to me. Which also means that in general, this doesn't happen when the person is in normal state or normal mood, right? And this is the complete concept behind state machine based programming. Okay, and you need to know only three things to be able to understand everything about it: state, events, and transition. These are the only three things. Let me give you some more example. Let's assume that one person is in a sad state right now, and in sad state the person can receive only two kinds of news. One is bad news, one is good news. So these news are nothing but event to the person in a particular state. Now, if a person is in sad state, I'm assuming that the bad news will not make any change to the state of the person. But if the person received an event which is a good news, the person's state will change from transition from sad state to happy state. And if the person is in a happy state, the person is receiving good news will not change the state. But if the person is receiving bad news, it will transition again from happy state to sad state. And this is the crux of state machine based programming. The idea is that at any point of time, identify the state of your system, what state your system is in. Because if you identify the state in your system, you know that what all events it can accept and what all transitions it can perform. Which means in a huge part of your code, which is hundreds and thousands of lines of code, if you know the state of the system, you know where to look into. What part of the code that will be executed in this particular state, what all events I can respond to in this particular state, and what all transitions I can perform in this particular state. And in this way, you can actually organize your code in a better way, in a state wise, okay, state, events, transition wise. Like when we talk about object-oriented programming, we created object-oriented programming to, keep data and functions, related functions together. The state machine based programming is all about how you can keep what is happening at the runtime. During runtime, your code will be in a particular state and you need to understand what all things you can do at that particular state. As a practical example, let's talk about something called login state. In the login state, there are only two events that can come. One event is that, submit button. Second event is forget password button being clicked. Okay. So you know that when I'm in this state, login state, there is no other event I can respond to. So one of these two events will come, and if the event is submit button, I'll move to logged in state. And if the event is forget password button click, I'll move to a different state where I am, assisting user to reset the password. So let's call it as reset event. Now I know that as of now, I'm talking about three states: login state, logged in state, and reset password state. So if I am in login state, I can only go to two states, which is logged in or reset password. Now think about it. If you are in logged in state, your program logic may prevent you to going from a login state without logging out. So from logged in state, you need to go to logged out state before you can move to login state again. Now look at this. You are defining how your system will work, how your system will respond to the things that are coming within a particular state. And if the things which are coming are not desired, you can just ignore those things or discard those events. And this not only safeguards your program, think about it, how your code will execute in runtime. You can depict it in a picture. You can create a state diagram in the easiest possible way. Okay. Now, when we talk about state machine based programming, there are some complications that may come after your code becomes big or your state becomes complicated. Like there could be a meta state where you have internal state machine within a meta state. Okay. But I have created these kind of state machines for a very long time, and some things are very easy in this. Like within a meta state machine you can replace which state machine will be called in there. And the best thing is about debugging, right? You know which state some problem happens, and you know the area of influence that can cause that problem. It's very similar to, let's assume you are giving your blood for some testing, right? And if you have noticed, whenever you talk to hospitals, the blood testing goes through various states, right? Sample collected, inside the lab, testing being done, reports are ready, reports delivered. Assume these are the states, right? But if you are getting some problem in sample collected state, you know what are people to talk to. You will not scramble around to find in lab why sample is not collected, or in the reports department why sample is not collected. The same logic, the same funda applies to state machine based programming. Divide your program into states. And let me tell you one more thing. You might be thinking, what programs can be divided into states? Let me tell you, any program that stays in memory or in execution long after you start that program has the capability of being a state machine. I'm not talking about a simple calculator kind of program where you input two number, it will give you the summation or multiplication, or something like input something, it will tell you based on the time, good morning, good evening kind of thing. No. But if you start the program and it is supposed to be running maybe for hours, if not for days, then that program is a perfect candidate for being a state machine. Because whenever the program is working or not working, it will be in a state. And that state you need to define, and you need to create and implement. And the best thing about state machine is that you can create a state machine in any programming language, be it be any programming language. Okay. There are some sample state machines being created in many other programming languages. There are state machine libraries available in many programming languages. You can make use of them, or you can create one. So that's all for today. Thank you all. Thanks for watching. See you again.